Alright guys, I've been doing some work on this tutorial, and I've actually come to a conclusion about it that the way I coded it was I used bit operators, but I've kind of just decided that that's too confusing and for me to explain in a tutorial, and it will result in a lot of copy and paste. So we're actually going to switch how we're doing it. We're going to get rid of our code bit operator stuff that we were going to do, and what we're going to do is we're going to use just an integer array to do all the operations, and it'll just be a much easier to explain, and the result will be the same. So first thing we're going to do is we're going to get rid of this char code in our square struct. We're going to change that to an integer array called possible, and that will be 9. And then we'll also have an int solvable. Okay, so what this is going to do is, if you remember when I was talking about the bit operators, it's going to be the same idea, except now it will look like this. So we're going to have an array of 9 numbers, and again, they will be zeros or ones, just like this. And they will correspond to something like this. If you think of these as the numbers and these as the index, so index, and I mean, you get the idea, but I'll just try and explain it as best I can so that when I start coding it, it will make sense to you guys. Okay, so basically what we'll be able to do is we'll be able to say, we'll go to the index at, say, 4, or it'll be 0 base, so 3. But we'll go to the 4 and to say, is 4 solvable? And if it's a 0, then or sorry, not solvable, but does it fit into this square? So like for here, we would say, does a 1 fit into this square? And because there's a 1 right next to it in the same row, this would be set to 0. And so that would be, or that'd be set to 1. So the answer would be no. At the start, these will all be zeros. So this solvable number will be set to 9 because there's 9 zeros. But then every time that one of these gets changed, because we're going to be going through, when we find out that this is a 1, we're going to go back through all these numbers here and all these numbers here, so rows and columns, and set them to be ones because they're not solvable. So when we do that, solvable will be subtracted by 1, and eventually solvable, when we've gone through all the tricks of Sudoku, solvable will be equal to 1, and therefore we know that that square is solvable. So that's the best explanation I can give. Let's get into the coding, and it should all make plenty of sense. Okay, so in puzzle.c setup puzzle, since we're not using code anymore, all this stuff is gone. And what we're going to do is we're going to replace that with an initialization loop where we initialize this possible array to all zeros. So that's going to look like, we're going to need another counter variable, so I'll call it x, and for x is equal to 0, x is less than, could be size of rows or columns, doesn't matter, x plus plus, and then it'll just be, I'll do proper convention, Sudoku I j possible, which is again, that's our array, possible x equals 0. So that initializes that array to zeros. Okay, so then we're going to re-loop through all the numbers. If you remember these 4 loops here, they loop through the entire puzzle, just kind of taking information from it. Now that we have that information saved, we can do stuff with it. So since it's going to be the same 4 loops, so I just copied and pasted that. We don't need this. And then just close them off. Okay, so what we're going to be doing here is we're going to do an if statement, and we're going to say if the number, here I'll show you. So we're going to go through all the numbers. We're going to look at this number and say, is this number have a value? No. So we go to the next one. Does this number have a value? Yes. Okay, well then what does that tell us about this previous number here? Or this number down here? Or this number over here? Well, because this has a number, and that number happens to be 1, it tells us that 1 can't go here, can't go in here, can't go anywhere on this row, and it can't go anywhere in this column. Okay, so we found this number or this square that has a number, so we're going to loop through the entire row and the entire column and say 1 cannot go in any of these squares. Okay, so that's what we're going to do. So first we have to say, well, is there a number? So by that we can do if Sudoku ij number is not equal to 0. So if it's not 0, it has a number. Then we can just say Sudoku ij solvable. So remember, that's our variable in here that tells us how many numbers are unknown, kind of. So because that has a number, we're going to say 0, because we know that it has 0 possibilities because it has a number. I think we kind of did similar thing up here, but anyways, so that's there. Then we're going to call our function that will loop through the rows and columns, and we're going to call that update Sudoku. Okay, so this will be the function that loops through those columns and rows, and we're going to pass it the puzzle, Sudoku, I, which is the rows, and j, which is the column number. So we might as well just write that right now, this function. So update Sudoku, we'll just return an int, update Sudoku. It's going to take square, triple star, Sudoku. That's just the puzzle. It's also going to take int row and int column, I and j. Okay, now this one, we're going to need another counter variable, so int x. We're also going to need an index. We're going to call it number. And that's going to equal Sudoku row column number. And I'll show you what we use this for. It'll just be an index. Okay, so we need another for loop. So for x is equal to 0. Now this first for loop will loop through the entire row. So what that's going to do is it's just going to start at 0 and go through every single one of these row squares. So x equals 0, x is less than size rows, x plus plus. And what are we doing in here? Well, we're going to say if Sudoku at x row, column possible, so this is our array at number, so this is our index, equals 0. Then we're going to say Sudoku, this column, x column, Sudoku x column, solvable minus minus. Then we're going to say Sudoku x column, this whole thing, possible So our array, oh sorry, this is supposed to be number minus 1 because it's 0 based, number minus 1. And then down here, number minus 1 is equal to 1. Okay, so what did we just write there? So let's do an example here. So we loop through our puzzle, and we come to this one that has a number. Okay, so this square here has a number. Okay, so we call update Sudoku. We call this function here, and we pass it the row and column that we found this number. So in this case, that's going to be row 0, column 1. Okay, we pass it to this update Sudoku function, which then loops through this is looping through our column, because column there. So it's going down. So it starts here, and it says if Sudoku x column possible, number minus 1 equals 0. Sudoku x column solvable minus minus. In this case, since it's at this will only matter for numbers that don't have a number, so zeros. So for here it won't really matter. Here it won't really matter. Here though, it will matter. So this square, upon initialization, all the arrays are going to be set to 0. So that means that it will be possible. All these zeros, these numbers are possible because it's just a 0. We don't know what number could go there. Now when we get there with our function, we're going to say 1 cannot go in this square. So we're going to go to the index at 1, and we're going to say, is that a 0? We do our check for 0. If it is 0, if this if statement is true, then we're going to say, we found one number that this square cannot be. So we're one step closer to solving it. So the solvable goes down from 9 to 8. And remember, when this solvable hits 1, we know that this square is solvable. So we reduce solvable, and then we change the array here to 1, therefore saying 1 cannot go in this square. I hope that makes sense. It works, is all I'll say. If it doesn't make sense, you can ask any questions. Okay, so we need to do the same thing for our row. Remember, this loops through the column. We need to loop through the row too. So I'll be simple. Just copy and paste that. This doesn't really have to get changed, but I'm going to change it. And then this the x changes place, row x, row, x, row. Okay, and that's all we need. So then we'll just return 1. Okay, so this is good for initialization. One other thing we're going to do is we don't need this char possible anymore, but we're going to change it to int unsolved, and this will be a global variable that keeps track of how many squares have been solved. So we'll initialize it here. It's int unsolved, and the puzzle starts out with 81 unsolved squares. Okay, so every time that we find a number, which is right here, if Sudoku is not equal to 0, then unsolved minus minus. Okay, so that initializes our puzzle in setup puzzle. Then what we want to do is we want to call a function called check puzzle. And this is going to go through, it's going to loop through every single number, and it's going to say, have we found any numbers that only have solvable equals 1, therefore, all these, let's say we hit a number like this, there's a 1 there, 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 there's a 1 there. Therefore, this number is 5. This square is equal to 5. That's what this check puzzle will do. So we'll put it in right before create puzzle, check puzzle. Okay, and check puzzle is going to take the entire puzzle, so square, star, 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 Sudoku. And so very similar, we're going to loop through the entire puzzle, so we can just copy and paste these for loops. That also means we need an int I, an int j, and we will need an extra counter. So just close those off. Okay, so we're going to start at each square, we're going to say if Sudoku I, j, solvable is equal to 1. Again, that's the thing we're saying, is this square solvable? So if it's equal to 1, then we're going to call another function called solve square. And this function will just figure out what number is supposed to go in there. And we'll just pass it the square. Sudoku I, j, and then, so now let's say that this number gets updated and it goes to, I don't know, 6. Let's just say that, okay? Then we find out that 6 actually goes here. Okay, now we know that 6 can't go in this column and it can't go in this row. So we're just going to recall update Sudoku, okay? So the 6 can't go here, can't go there, can't go, you know, etc. You get the idea. So that's why we're recalling, that's why we're recalling update Sudoku. So we'll just call it there, update Sudoku, and it takes Sudoku and I, j. So same thing. Pretty simple function. So we'll just, return 1. Okay, so now we have to write this solve square. And then we'll finally start seeing some stuff. I'm going to create a new file for this, and we're just going to call it square.h. So, .c, sorry. And remember, our make file will automatically compile this, so that's pretty cool. So pound include Sudoku.h. Then we'll just write our function here. So int solve square, and it just takes a single square, so that's square star square. So save that. Now what we're going to do here is we need a counter variable, so int x, and we're just going to loop through that array here, and we're going to find the spot that has 0. So, you know, we check here, no, it's not this square, not this number, not this number. Oh, it's this number here. So that's what we're doing here. So x equals 0, x is less than size underscore rows, doesn't really matter which one, x plus plus. And then we're going to say if square possible x is equal to 0, and this is the number that we're saving. Then what we do is we say square number is equal to, it's going to be x plus 1, because remember, it's 0 based. So you would start at 0, 1, 2, 3, 4. So in this example, it would actually be 5. That makes sense. So square number x plus 1. and then square solvable. We're going to set that to 0. And then we're going to call our global variable unsolved and subtract 1 from it. Again, unsolved just keeps track of the number of solved squares, and we know that we have to keep going until unsolved equals 0. So that's just a way of doing that. So I think that's pretty much it there. And yeah, I think that's pretty much it. So now we need to call these from main. So check puzzle, and it takes Sudoku. Now we're going to want to check if it's done anything. Well, let's actually just run it now. So make segfault. Well, that's no fun. Make clean. Make segfaults again. Well, goodness me, why is it segfaulting? Did we initialize unsolved? Oh, I think I know what the problem is. Here in setup puzzle, we don't actually return Sudoku. So this actually just returns nothing. And then we try and pass nothing to our function. So this needs to return our puzzle. So I return Sudoku. Yeah, so we assign it here. It gets assigned there, and then we pass it. That would do it. That would do it for sure. So let's try again. Make clean. Make. There we go. Okay, so that worked. Okay, so we want to check and see if it's actually done anything and solved anything. So we're going to modify this print puzzle function. So print puzzle right now takes an int. We're going to change that to square so we can pass it the entire puzzle, square star star. And then the only thing we need to change is instead of puzzle ij, prints out puzzle number. And that means we have to call it after the puzzle's been set up. So, and then instead of taking puzzle, take Sudoku. So then let's also print it there and do a printf with a line break to see, kind of give us some space. Okay, let's try that again. We have to update our .h. Oh yeah, we haven't really updated this at all. So that's square star star. Then let's actually do that for these as well. So in solve square, add that in there. And then puzzle.c, there's a few here. Check puzzle. I think that's int. Int check puzzle. And int update Sudoku. All right, let's try this now. There we go. Okay. So there's not enough information. We're not kind of doing enough tricks right now to actually solve anything. But just to test if it's working, let's modify our initial puzzle. So that's down here in create puzzle. Let's kind of change the starting puzzle. So we're going to add 8 here, 7 here, and 3 here. Okay, so that means that this square needs to be a 9 because there's no other spot for a 9 to go than in here. So if our functions are working, once we save that, a 9 should show up here. So let's see if that worked. So clear it, make, and we don't see a 9. All right, sorry guys, big blunder on my part. In our setup puzzle, I forgot to initialize solvable. So remember, we have this solvable variable which basically keeps track of how many zeros are in this array. And when this array, every time that we change one of those zeros to ones, we say, oh, we know one more step about this, so we're gonna reduce that solvable by one number, and then when it goes to 1, then we say, oh, there's only one possible number that can go into this array. But our mistake here was we actually didn't initialize it to 9 anywhere. So we need to do that because obviously, yeah. So ij solvable equals 9. Okay, now let's try that. So if we try that again, we just hit make, then we should see that it works. And as you can see here, this is the number we're trying to manipulate to get to be 9, because, well, there's 8 numbers in this row, and so we know a 9 has to go in here. And again, this is probably an unsolvable puzzle now, but just for demonstration purposes, as you can see, it works, and the 9 is now there. You can even look around and see that since it solved other numbers too. Again, probably wrong, but see, there's 4 here that was not there before. So it's yeah, it's interesting how it works. Now we're still a bit a ways from actually solving this puzzle, and we should actually reverse it to the original. So that 8 was a 0, that 7 was a 0, and that 3 is a 0. Okay, so yeah, anyways, we solved one square, which is that's a big step. So we'll start working with boxes, taking the same principles since, yeah, and that's what we'll do in the next tutorial.